Yeah, so I just want to talk about question one pretty quickly. I think it's a pretty good question one, just because my impression of question ones is like a good question one should be like kind of easy to solve, but you can still make mistakes and lose like 1 or 2 points here and there. Um, yeah, so I guess I don't know, like maybe you guys are rusty from not having done much, but it's kind of it starts off I think a bit harder than senior contest probably would, depending on how you're feeling. But yeah, so question one, I guess. So Alan came up with most of the solution I'm about to present, but um I think you got to take some care to write it up. So we wrote it up on the homework submissions overleaf if you want to see what our write up looks like. But basically, to sketch the proof, we got that um the so maybe I could even put it up while we're doing it. So some bits we might have could have written a bit more, but basically our the answer we had was 15, and 15 was the number of primes that were between 1 and 50. And so we proved in one direction that um so in one direction we proved it has to be at least 15. And so to prove that, we imagined that W was the Williams number's 1. Okay, and the point is that if the number's 1, the answer will be like no to all the questions. So if you never ask, if you never ask about prime numbers, then you never tell the difference between 1 and that prime number. Because for a prime number, the answer is also no to all the questions except for when they ask about the prime number itself. Okay, and so that means you have to ask about all of the primes to conclude that it's 1. Um, and therefore you need at least 15 questions. Okay. In the other direction, so this is the direction where I think you could also lose some marks if you're not careful. So we're saying that you need at most 15 questions. So our proof goes like this. So if we ask about all the primes, and we also ask about all the powers of the primes, then that will definitely tell you what Williams number is, because every number has a unique prime factorization. So that means, so the extra numbers would be like 4, 8, 16, the powers of 2, so that's like another 8 numbers, right? So that means we can definitely get it in 15 plus 8 questions, but we don't actually need to ask an extra 8 questions because, okay, it says my internet connection is unstable. That's not good. Um, so we don't need to ask an extra 8 questions because when you answer yes to like the question for 2, then you don't need to ask like the questions for these numbers here, because um they times the 2 to bigger than 50, right? So actually, even though it seems like there's 8 more questions, you never actually need to ask. Like some of the questions are mutually exclusive. So like here you get the powers of 2, but then you lose these 6 numbers. So, and the same applies for 3, 5, and 7. So you never actually get more than 15 questions, and that's the answer. Does that make sense?